Hey there, I'm back. All right, so hopefully you finished the task, or most of you have finished the task at this point. Maybe some of you have already started the assignment. I just want to make sure that this is clear what it is we're asking you to do. So I do not want you to try to use use a calculator on this. Okay, I want you to basically work your brain a little bit and try to figure out three numbers that are in between the two given numbers. Right? Some of these will be a little easier than others. These ones over here with radicals might be a little more challenging. Ooh, radicals with fractions. I mean, can it get any better, right? Okay, so let's go to number 2. I choose that one. So what I like to do, if the sub has not passed them out, maybe pause it right here. Let's have everybody go ahead and get the handout from me so you can make some notes on this as we go. I'll pause for a moment, or I guess you could pause for a moment. I'll just keep going. All right, here we go. So we're picturing a number line, and if you need to, you draw a number line, right? So I'm going to picture, here's like -3, -2, -1. I'm working on this guy right here, so I'm going to focus on those numbers, like where they would be. Now, -2 and a fourth, so 0's up here, -1, -2, -3. So -2 and a half would be here, -2 and a fourth would be like somewhere in there. -1 and a half would be somewhere in there. So I have to find three numbers that are in there. Okay, one that I know for sure. Well, let me go ahead and mark this a little bit darker. That's -2 and a fourth, and this right here is -1 and a half. One that I know for sure, that's an easy one. -2 is in between there. So that can be like, maybe we put something like that in the middle. But let's see. What's on its way to -2 and a fourth? So we need a fraction like 1/4, but do you want it bigger or smaller than 1/4? And it turns out we want a smaller fraction. So think 1/4 of a pizza. What's a slice of pizza that's smaller than 1/4 of the pizza? If it's a large pizza, 1/4 of the pizza is plenty of pizza for one person probably. So if you wanted maybe just to feed a little kid, maybe a little 6-year-old or something, maybe you want to give them 1/10 of that pizza, right? So that would be a smaller piece. So I'm thinking -2 and 1/10 will do the trick. Okay. And then let's see, we can come on the other side of the -2 and say here's -1, -1 and a half. If you forget the negatives for a second and just think we're counting to bigger numbers, I need like -1.5, -1.6. You could do a decimal if you like. If you want to go -1 and 6/10, you could do that. That would reduce to -1 and 3/5. You have lots of options here. Lots of options. In fact, that's kind of the point. You have lots. In fact, you don't have just a certain number of options. You have an infinite number of options. It's just a matter of finding three that are easy enough to write down, that you know for sure are between those two. All right, again, no calculator here. We're just reasoning through it. The negatives tend to confuse people as well because it feels like we're going backwards. I also chose number 4. So I'm going to take a sneaky way out because I don't know exactly what the square root of 3 is. But would you agree that square root of 4 is in between there? Yes? Square root of 3, square root of 5, makes sense that square root of 4 is in between there. Which means you could leave it as square root of 4. If you wanted to impress people, you could go like this. I know that's a 2. You could also leave it as square root of 4. How about this? Square root of 3.5. That's definitely bigger than square root of 3. And it's for sure smaller than square root of 5. So then how about, over here, maybe it's like 4.5 or 4.6 or 4.7. As long as that radicand, the number inside, is less than the 5, we are good to go. All right, so some might say that's a sneaky way of doing it, but to me, I don't think it's sneaky. I don't think I'm cheating. If they're looking for decimals only, maybe they would say in the directions, don't give radicals as your answer, but they gave me radicals. I think I can give them radicals back. So I'm going to take that liberty. All right, let's go ahead and move down to the second set here. It says the area of a rectangle is given in the form of a trinomial expression. Let me back up. It says factoring quadratics. That's what you're doing here. Find the equivalent expression that shows the lengths of the two sides of the rectangle. I've chosen 24 just because it's got some bigger numbers. Here's what I'm looking for. I know it's x times x. You've done enough of these, I think, at this point. X times x is how you get an x squared. So tell me about the signs. Are they going to be both positive, both negative, or one of each? And by one of each, I mean one positive, one negative, right? Well, here's what I'm going to do. I'm going to go find numbers that multiply to get 51. For example, 1 times 51. If I add those, is there any way I'm going to get a negative number? No. If I make them both negative, they now multiply to get a positive, but they add to get a negative 52. So good news, bad news. Good news, they multiply to get a positive still. Another set of good news is they add to get a negative. The bad news is they don't add to negative 20. So instead, we go to our next numbers. Does 2 go into 51? No, because 51's odd. Does 3 go into 51? And if you know the cool trick, 5 plus 1 is 6. 3 goes into 6, so therefore 3 goes into 51. Nice little technique. It turns out 51 divided by 3 is, wait for it, 3 times 1 is 3, subtract to get a 2, bring down the 1. 3 times 7 is exactly 21, remainder 0. So negative 3 times negative 17. Now do those add up to negative 20? And the answer is yes. So we put a minus 13, we put an, minus 3 and a minus 17, and we are done. Standard form given, factored form is what we just came up with. Those are our dimensions. All right, so you can do the diamond routine if you want to on a separate piece of paper. If you want to draw the diagrams like we were doing in part of the task today, you can do that. Pay attention to the signs though. Little tip for you. What multiplies to get a negative? 2 positives, yes or no? This is where you say something, yes or no? No, 2 positives will multiply to get a positive, correct? How about 2 negatives? What's a negative times a negative? Tell me now. That would be a positive, right? So it won't be 2 positives, it won't be 2 negatives. So immediately I know this much. X plus minus. Or x minus plus. I don't care what order you do those. All right. How about this guy right here? X plus plus, yes or no? If I put a plus here and a plus there, you'll multiply to get a positive, but you'll never add to get a negative. So it better be a minus plus or minus minus? Better be a minus. Think of it, if you do a plus, a negative times a positive is not a positive. So it has to be the same sign. So a little tip for you, that's a minus. A little tip for you, if C is positive, these have to be the same sign. There is no other way to do it. So they have to be the same sign, both positive or both negative. You look over here, that tells you both negative. All right, and if you know the numbers, we can go ahead and do that. Let's see, 1 times 24, no. 2 times 12, no. Let's see, I'm thinking negative 1 times negative 24, negative 2 times negative 12, no. Negative 3 times negative 8, no. Negative 4 times negative 6, yes. And we are done with number 16. Again, that kind of looks like a plus 6. That's bothering me. Everybody notice that's a minus 6. Okay, so that's how you do that set. And the last piece, I don't think you need too much from me on this one. Graph each parabola. Include the vertex and at least 3 accurate points on each side. So I would like you to find the vertex for each one. Okay, you can go ahead and write that down so you don't forget. That's kind of our regular routine anyways. We've been doing that for a while. We need 3 points on each side of the axis of symmetry. So that means if you got a parabola, you need 1, 2, 3 over here, 1, 2, 3 over there. Okay, so you're going to have a total of 7 points. All right, then describe the transformation in words. That's down here. So for 29 and 30, your description is below the graph. So a quick little description. When we say transformation, what we mean is, did you flip it upside down because there was a negative out in front? Did you shift it or translate it up or down or left or right? If you know which way it's been moved, you just tell us those in words. All right, I believe that's it. It's a 1 through 30. I think you're going to go fairly quickly through that. Hopefully you can get a bunch of it done in class, and I will see you next time. Good luck.